Hello students, welcome back to this channel. Today we will solve some textual examples of chapter number 3, Motion in a Straight Line. We have already completed the first two examples of this chapter of NCERT textbook. Okay, so now today let's start with the third example. So let's start with example number 3.3. Example 3.3 is obtain the equations for constant acceleration using the method of calculus. Right? You have already studied about this equation like V equal to V0 plus AD. Right? Plus half it square and v square minus v0 square is equal to 2AD, or you can also write 2AX minus x0, that is the displacement, right? So I already studied these three equations for constant acceleration, but now the question is you have to derive it using the method of calculus. Okay, so let's start. Let me erase this. Okay. Okay. So now we know that for constant acceleration, remember here we are taking constant acceleration. Okay. This equation can be are only valid for constant acceleration. So now what is the formula for instantaneous velocity? Sorry, instantaneous acceleration? dv upon dt, right? The formula for instantaneous acceleration is dv by dt. Okay, so I can take this dt on this side. A dt is equal to dv. So this was the formula for instantaneous acceleration, means at that instant. But now, if I integrate it, okay, dv means the velocity, very small amount of change in velocity, right? So if I integrate this, okay, or else I take integration of dv and here. Now, see, this is dv and this is dt. So if I take integration from t equal to 0 to t equal to t, assuming that initial velocity v equal to v0 and final velocity is v. So what I will do, I will integrate from 0 to t and here v0 to v. Clear? I will indicate for the time 0 to time t. So velocity at t equal to 0 is v0 and t equal to t is v. Okay. So now see when I am taking this integration, what is integration of dv? V, right? So v, this is equal to a acceleration is constant, right? So constant term we take it out. So what is integration of dt? T. 0 to t. Now this is definite integration. So what we are doing first, put the upper limit and then the lower limit. So v minus v0. This is equal to a constant t minus 0. So v minus v0 is equal to AD. So v equal to v0 plus AD. I'm taking this v0 on this side. So I got the first kinematic equation as constant for constant acceleration. That is v equal to v0 plus AD, where v is the final velocity, v0 is the initial velocity, a is the constant acceleration, and t is the time interval. Why I'm taking time interval? Because initial time was 0. So delta t will be equal to final time minus initial time, that is equal to t. Clear? So v equal to v0 plus AD. So this is the first equation. I'm noting it down here. V equal to v0 plus AT. We had derived this. Okay? Okay, so just note down the first equation. Okay, we had here the first equation. Note it down. Okay, now let's see the second one. Okay, for second, what is the formula for instantaneous velocity? V equal to dx upon dt. So we will just use a similar method that we did in the first. V dt equal to dx, or dx is equal to v dt. Where v is the final velocity, we can take here. Then what was the formula for the final velocity? V0 plus AD. Okay, I'm not a final, but velocity at any time, v will equal to V0 plus AD, where V0 is the initial velocity. So dx, clear? So now what I will do, I will integrate it. Dx equal to integration of v0 plus at dt. Now see, when I take the initial position as x0 at time t equal to 0. At time t equal to t, let the position be equal to x. So when I'm integrating dx, it's from x0 to x. And for time dt, it's 0 to t. Okay? So now, integration of dx is x. V0 is the constant term. So it will be V0 t. Okay? See, I'm splitting it down in this way. This will be V0 plus at dt. This will be equal to V0 dt plus integration of at dt. So V0 is constant, integration of dt, a constant, integration of t dt. Right? So what is V0 constant, integration of dt is t, plus a constant here. Okay, so t dt, integration of x raised to n, x raised to n plus 1 upon n plus 1. Here the power is 1. A is constant, so I have taken it out. So t raised to 1 plus 1, 2 upon 2. Okay, and the limit is 0 to t. Clear? So no need to solve this. You can write down directly. Clear? So integration of V0 dt, V0 t. Integration of AT square by 2. Okay, so now let's put the upper limit x minus x0. Okay, if you don't know this, then just watch the previous video of differentiation and integration. Then you will get an idea about integration. V0 t, V0 as it is, t plus a t square by 2 minus V0 into 0, that is 0 plus a into 0 square by 2. So 0 plus 0, this will be equal to complete 0. Clear? So that implies x. When I take this x on this side, x0 plus v0d plus 1 by 2 ad square. Clear? You might have studied the formula like x equal to v0 t plus ad square. In that case, we are taking x0 as 0, means initial position 0. At that time, it will be x equal to v0 t plus half ad square. But if the initial position is not 0, then we will take it x0. So see, we have derived the second one, x equal to x0 plus v0t plus half ad square. What we did? We took the formula for instantaneous velocity. Okay, then we took dt on this side. Instead of v, we took the first formula, v equal to v0 plus at, integrated it, and finally we got x equal to x0 plus v0t plus half at square. Clear? So note down this is the second equation for constant acceleration. Okay, now let's derive the third one. You can use the previous derivation also that you have learned, but if the question is using the method of calculus, then you have to solve only by this method. Okay. Now see, for third one, again I will use the formula for instantaneous acceleration. A equal to dv upon dt. Now see, what adjustment I am doing? I am multiplying it by dx, dividing it by dx. Clear? So now I am rearranging. What I did, I just took the formula for instantaneous acceleration. And this is the extra thing that I had done. I have multiplied by dx, divided by dx. Now I will rearrange dv upon dx into dx upon dt. I just change the place of dt and dx. So now what is dx by dt? This is equal to v, velocity, right? Instantaneous velocity. Now, v dv upon dx. Now let's rearrange dx on this side. A dx equal to v dv. Okay? Now let's integrate it. I'm taking v dv on this side and a dx. Now see, what is the lower limit? Let's take that at x equal to x0, initial position velocity will be equal to v0, initial velocity. And at x equal to x, the final velocity let it be v. So here it's dx, I will integrate it from x0 to x. And here it's v dv, I will integrate from v0 to v. So now what is integration of v dv? Remember, integration of x dx, x raised to n plus 1 upon n plus 1. So here v raised to 1 plus 1 upon 1 plus 1. So v square by 2. So this will be v square by 2, v0 to v. And this a acceleration is constant. Don't take it as a square by 2. It's dx. So if it was x, then it would be x square by 2. A is constant. So I will take it outside. Integration of dx is x. Clear? So now let's put the upper limit. I will take this 1 by 2 outside. Okay. Now remaining is v square. V square minus v0 square. I can also write down v square by 2 minus v0 square by 2. So again 1 by 2 I can take it common. Equal to a x minus x0. Let's take 2 on this side. V square minus v0 square equal to 2a x minus x0. This is the third kinematic equation for motion in a constant acceleration. So v square minus v0 square equal to 2a. We are also derived the third one. You might have studied in the lower standard like v square minus v0 square equal to 2a d, where d was displacement, final position minus initial position displacement. Clear? What I did here, I took the formula for instantaneous acceleration, multiplied, divided by dx, rearranged dx by dt velocity. And then I took dx on this side and integrated. Clear? This was the third equation, so we had derived all the three kinematic equation for a motion of a constant acceleration and using the method of calculus. Clear? So note it down. Now let's move to the next example, that is example 3.4. Example 3.4, it's an important numerical, right? See, it is given that a ball is thrown in a vertically upward direction from a multi-story building with a velocity 20 meter per second, right? Means let's say you are standing on the terrace of your house. Okay, similar to the top of multi-story building. Clear? And means this is the terrace, and from here you are throwing the ball. Right? It will rise, and after that it will fall down to the ground. Clear? So this is the situation, right? The height of that building is going to be 25 meter. Now you have to find out how high will the ball rise and how long it will take before it hit the ground. Yeah, let me explain you the question. See, this is a multi-story building having a height of 25 meter. From this position, the ball is thrown upward. Okay, let's take from here. The ball is thrown upward. Let's say this is the maximum height. This is the maximum height that is gained by the ball. After that, what will happen? The ball will fall down. So this is the distance covered by the ball after reaching its top height. Clear? So ball will start from here, go move here, top position, and then it will fall down. This is the situation. Okay. So before solving, let me write down the three kinematic equation. V equal to V0 plus AT, X equal to V0 T plus half AT square, and V square minus V0 square equal to 2AD or 2AX. Clear? Where x is the distance covered. Okay. Now see here, when the ball was thrown from this position. Okay. First, let's calculate this how high. Already 25 meter is there. Right? So what is the velocity here? Okay. At this place, I am calculating it here. Velocity V0 is equal to, it's given 20 meter per second. In which direction? Upward direction. Okay. Now see, when you are throwing anything at the top position, right? What happened when it moved till here, and after that it came back? So what is happening? When I'm throwing it upwards, velocity is decreasing, 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 zero, and then it is coming back. Means to come back, its velocity will be zero at one position, and that will be the maximum. So at this position, the velocity, final velocity is zero. Clear? At this position, the final velocity is zero. Okay? And what is the acceleration? It's given that when you're throwing a ball upward, which acceleration? Gravitational acceleration. And coach has given take it as 10, but as the acceleration is in downward direction, I will take it as minus 10 meter per second square. Clear? Okay. So these are the given things. Okay. Now, how high means we have to find out this height. Clear? We have to find out this height that h0 is equal to question mark. Okay, so let me write down this given thing in this way. V0 equal to 20, A is equal to minus 10, and final velocity V is equal to 0, H is equal to question mark. Okay, so now, so this is only the first part. From these three equations, H means, let's take X, and that is equal to question mark. We have to find out X, this height. Okay, so what will be, which equation I can use? Here we are not having X, here we are having X. Do we have V0? Yes. Do we have time? No. Do we have acceleration? Yes. Okay. So what we will do? We are not having time, but using this equation we can find out the time. because we are having the final velocity, initial velocity. So V equal to V0 plus 80. Clear? So what is final velocity? 0, initial velocity 20, acceleration minus 10, and time t. Clear? So 0 is equal to 20 minus 10t. 10t is equal to 20. T is equal to 2 seconds. I got the time. Right? The time taken to reach the maximum height is 2 seconds. Clear? Now I will use the second kinematic equation. Now I am having the time. So now x equal to v0t plus half at square. What is v0? 20 times 2. Half acceleration minus 10 t square, that is 2 square. So 20 into 40, 2 ones are 2 minus 5. So 2 square 4, 4 into 5, 20 minus 20. So this is equal to 20 meter. I got x equal to 20 meter. So how high the ball will rise? Okay, 20 meter. I got this 20 plus 25, so total is 45 meter above the ground or 20 meter above the building. So I can write it down that ball will rise till 20 plus 25 equal to 45 meter above ground. Okay. Now, so if there is an MCQ asked like this way, then the option may be 45 meter above ground, okay, or else 20 meter above the multi-story building. Clear? So this is our first answer. Clear? Okay, don't move, write down 20, write down 45 meter. And also write down the detail if you are writing 20, 20 about the multi-story building. Okay, so this is not the main answer. Our main answer is this one. Okay, now this second part. How high will, sorry, how long will the ball take to hit the ground? Means now see here, from this is the building, the time taken here T1, and from here this total time T2. Okay, clear? So this is T1 only this much. Okay, and T2 from here to here. So I will take find out two times. Okay, so first let's find out from here to here. From this to this. Which quantities now I am having? I am having height x equal to 20, v0 equal to 20, final velocity that is equal to 0, time equal to 2 seconds. Okay, I already got the time 2 seconds, right? So now what is my aim? T1 I got 2 seconds. So I'm writing here that T1 is equal to 2. What is T1? Time to reach maximum height. Clear? Now I want time T2. Okay, from here to ground. Clear? So now, what was the initial velocity here? Now the initial velocity changes. Now let me erase this. From here to here, T1 equal to 2. And from here to here, T2 is equal to question mark. Now what was the initial velocity at the top? Here, the initial velocity V0 was equal to 0. Right? Because the ball was reaching at this position. Now velocity 0 coming back. Clear? What is the acceleration? G, and that is equal to minus 10. What is the displacement, or what is this height? 20 plus 25. 20 plus 25, that is equal to 45. Now let me write down time here for this. Okay, that is equal to 45. Okay, or else time to reach maximum height T1. Clear? Now see. Initial velocity 0, acceleration minus 10, uh, total height 45. I need to find out time. So can I use this formula? I'm not having final velocity. Can I use this formula? I'm having x, I'm having v0, I'm having a. So only thing is time. So x equal to v0 t plus half at square. So here what is x? 45. v0 0. Time, let's take t2. Half. Acceleration minus 10. t2 square. So 45 will be equal to 0, 5 minus 5 t2 square. Clear? So just a minute. Okay, no, no. See, here I will take a equal to plus 10 because the ball is moving downward. Okay, or else I can do one thing. The position x will be minus 45. Why? See, when I take y-axis positive, it will be upward. When I take downward, it's negative. So x is equal to minus 45. Okay, let me change it here. Minus 20 plus 25 minus 45. So minus 45 minus minus gets cancel. 5 ones are 5 nines are. So t2 square equal to 9. That implies t2 equal to plus minus 3. But time cannot be negative. So t2 is equal to 3. So total time t1 plus t2 equal to 2 plus 3 equal to 5. So it will take 5 seconds before hitting the ground. Okay, clear? So let me revise what I did. I split it into two parts. Okay, this was the first part, and this was the second part. In first part, I just took this much. Okay, initial velocity, final velocity, acceleration. First, I found out the time, and using the second equation, I found out the x. So the total height was 20 plus 25. In second case, t1, we already have the time here, right? So 2 seconds. Okay, now we have to find a time from here just hitting the ground. So initial velocity, acceleration, displacement, I have taken minus 45 as it is moving downward. Acceleration minus 10 because it is downward. So using this equation, I found out 3 seconds. The total time, 2 plus 3, 5 seconds. Okay, so just note down example number 3.4. Okay, students, so that's it for today. Thank you.